All right. Good morning. How are we all doing this morning? Enjoying day 2 of NDC? I'm getting some nods. Fantastic. Well, I'm glad to hear that you're all enjoying NDC so far. This is my first time in Denmark, by the way. I'm originally from the UK, hence the accent, but I've traveled all the way from Melbourne, Australia. I'm actually on my honeymoon, kind of, at the moment. So my wife is in the audience. We've just spent a wonderful 3 weeks in Italy, so I've enjoyed the good weather, the good food, and come to Denmark and continue to enjoy the good food. And the weather is very similar to what it is in Melbourne, so thank you for making me feel welcome. But no, it's a beautiful country. I've really enjoyed the past couple of days now we've spent in Denmark. It's a wonderful place. I should come back again. Depending on how this talk goes, you guys might kick me out of the country. I don't know. Anyway, welcome to this talk on platform engineering in the age of GenAI. This is a very ambitious title. I was going to say topic title to have, especially when you go on holiday for 5 weeks, because you kind of assume that, oh, the topic's not going to change that much. But with AI, things seem to change daily. Well, there's always a new thing that's kind of coming out. So this talk has evolved over the past few months that I've done it, so let's see where we are today. About me, I am a senior software engineer working for Microsoft. I work in the industry solutions engineering team, so we do a lot of coding and coding along with customers and building stuff for customers. Previously, I was a Microsoft Azure MVP focusing on Kubernetes and open source, more on the open source side of things. So projects like Dapper, that was really interesting to me, and I love sharing my knowledge about Dapper. I used to be a rugby player, but now I get my injuries just from being old. I'm in my mid-30s, so my knees aren't working as well as they used to. But yeah, anyway, and I talk at conferences. I'm very fortunate to be able to speak to developers, platform engineers, and anyone who wants to listen to a variety of audiences around the world. I do some stuff on YouTube. I haven't done it for a while. Life has been pretty busy. But I talk about Azure, .NET. Those are kind of my main things that I like to talk about. And here's hopefully the only AI slot for today. This is not because I've come to Denmark. I build Lego heads on the side. I love the Star Wars Lego heads. So yeah, I thought instead of doing like the cartoon that everyone was doing, that's what I was aiming for. And feedback has been, yeah, that's a bit creepy. Anyway, let's get that off. Okay, so this talk, I'm very aware that I'm representing Microsoft, so I'm going to do that kind of social media equivalent thing, like thoughts on my own or opinions on my own. This talk will contain my own opinions, obviously based on the work that I do at Microsoft, but I will be slightly opinionated about it. If it seems throughout the talk I make a joke of things or I make light of things, I'm not laughing at that particular thing. It's just how I process things that happen in our industry sometimes. I like to kind of confront it with humor. But if you do have questions, if you have thoughts you want to share, please save them to the end. I think we may have a microphone towards the end. If not, I will just repeat the question back to the whole audience, because we're filming this as well, so the online audience can hear the question as well. So how many of you would actually call yourselves a platform engineer? Some of you, hands up. It's kind of it was evolved from this position, DevOps engineer, which was kind of a weird position within itself, because DevOps is a process, it's not really a position. I think it was a very much a kind of a recruiter strategy saying, okay, we need to appear, or our organization needs to appear to do DevOps. So let's go and find some engineers to do DevOps, not realizing that DevOps is kind of everyone's responsibility. Now, with platform engineering, we kind of reverted back a little bit on that thinking as well, because a lot of teams would kind of build out kind of golden paths to develop and deploy products and solutions. And they'd actually find that they'd be managing too much. The cognitive overload, which is a strange term to talk about now, because when we associate cognitive overload, we talk about agents running off and doing things, and we're trying to keep track of what they're actually doing. But cognitive overload in the context of kind of DevOps is like, okay, now I'm responsible not just for building the thing, but for testing it, making sure it's secure, making sure it's legally compliant, and I've got to know things. And I also have to automate those things that I need to know now in order to kind of do DevOps properly. So my kind of opinionated take on platform engineering is that we're essentially doing or building, internal products or internal mechanisms and golden paths to reduce that cognitive overload for developers. So developers can get back to doing what they do by delivering value, by actually building innovation, a bit innovative solutions and building things. Kelsey Hightower's got a really good saying around this, that platforms aren't just these magical APIs. I think the trap that we kind of brought with us with the DevOps kind of thinking that, we need to go out and just build a platform, or I'm going to buy or adopt a Backstage, something like that, or build an internal developer portal where it's an actual product, it's an actual thing, and I've got platform engineering now. And it's not necessarily that. It's just basically agreements between human beings through APIs how we're actually going to do our work. Because if you buy a platform, or if you kind of build a platform and you're forcing everyone into it, that's kind of defeating the point. No one's going to want to use or love a platform that they're forced to use. Essentially, platform engineering is about making it the path of least resistance. And really, quite simply, it's just about how we can make lives easier for developers. It's how we can help them to be self-sufficient. Now, a lot of us would say that kind of gets translated through automated pipelines, integration tests, security scanning, stuff that kind of just works. You kind of build it out, and say you're building an application, you're deploying a binary somewhere, and you want to make sure that your security teams are going to sign off on it. So you have some steps in there. Maybe you're scanning the container image that's being generated, or you're doing some static code analysis. And you want to make that as easy as possible. And then it's kind of standardizing that across teams and organizations to make that adoption, or make that a bit easier for other teams, so they're not writing stuff from scratch. So how many, just to use that as an example, how many of you have actually kind of working with a security team within your organization, like after you've built something, you've kind of asked for permission to deploy it? It's a bit tedious, right? Where and have you ever been rejected, or has it ever been rejected based on you haven't used this particular tool, or you haven't done it in this particular way? That has happened to me. It's good to see that there aren't many nods in the audience. Having gone through that pain myself, essentially the idea of an internal developer platform isn't like a shiny new portal somewhere that you've just bought. It's kind of adopting kind of an automated way of doing things to make life easier for you. Also, another question: how many of you have been in teams where your team was like the first team to deploy applications to the cloud? One or two. Was it painful for the first time, writing infrastructure as code templates and just basically figuring out how it all works? I've been involved in teams like that, particularly I used to work for a bank, and trying to do that in highly regulated environments as well, where you're working with different stakeholders. That can be a bit of a mission as well. So really, some forms of platform engineering can really be simple as just kind of like pipeline templates or infrastructure as code modules. And there's more nuances to that, because particularly with something like Terraform, you have Terraform registries, and there's also bicep registries. But essentially, that could be as simple as what platform engineering actually is. Then AI came into the picture. The developer experience has transformed incredibly since 2023, 2022 even. Richard was talking about in his keynote yesterday. Anyone recognize any of these? Everyone's nodding. Yeah. Yeah. Coding assistants are great. I'm here to tell you that. I'm not here arguing that coding assistants are bad. I'm not saying that because I'm working for Microsoft and I use coding assistants every day. But they have transformed the developer experience. Now, just to take off my Microsoft hat at the moment, we kind of started off basically selling the idea that if you're using Copilot, or if you're using Claude or Codex or whatever, that you'll become this 10x engineer and you can deliver features super fast. So, my clicker died, and then it came back to life. So yeah, AI is going to write the code for us. We're going to ship features overnight. It's not going to take us weeks to develop something and ship it to customers. This is going to be simple for us. Whereas the reality is, even before AI, documentation wasn't something, I think, as an industry we did too well. How many of you be honest, didn't document your stuff too well. It's all right, we're in a safe space. They can film me, everyone had their hands up. No. There was inconsistent tooling amongst teams as well. And with AI, a lot of kind of like the early kind of vibe coding patterns we saw was just kind of YOLOing it. I know Copilot has got a YOLO mode, which is, I've never used it, honestly, because that seems to me like you're just asking for trouble. My clicker's doing something funny today, but that's okay. I'm by the keyboard. So yeah, just ChatGPT, dude. I'm a big South Park fan. Now the data, we've kind of moved on a little bit from this data, but I have included it. Basically, the idea is, from the vendor perspective, there is a marketing arm saying, just adopt us, and you'll be faster, your engineers will be more productive. And that came from a really narrow 2003 study. And more, as time has gone by, there have been more studies where senior developers, particularly from Microsoft and Accenture, were asked, has this increased your productivity? And you'll see those kind of metrics will say, yes, we've raised more PRs, we've committed more code. And I think the kind of looking at it as a volume or a percentage of stuff that we've pushed and committed doesn't necessarily mean that we're more productive. Yeah, we're producing more, but we're not producing more in value, right? And this studies actually showed that. So senior developers kind of said there's no statistically significant gain that we're actually getting. We're pushing more, yeah, but we're not actually being more productive. And in the open source world, there was a study where there was more code was being produced. There was faster being produced, but reviewing it was taking a long time. I think open source has kind of led the way of its skepticism towards AI for a good reason. I'm not a maintainer for a large project. Have we got any maintainers in the room of large projects? No? Okay, well, I'll empathize based on an assumption that it must be very taxing for you've got a large project and lots of people are trying to commit and trying to contribute, which is a good thing, but trying to sort out the AI slot from the meaningful contributions will slow you down, whether you're in an enterprise or you're working on an open source project. Now, I've included a study that was done kind of pre-Claude Mythos about how vulnerabilities were being introduced. Mythos has kind of changed that perspective. Richard had a slide yesterday showing how Firefox have kind of resolved some of their security vulnerabilities. That was, I believe, using Claude Mythos, which is apparently quite a powerful model. I haven't used it. But I think we're still at a stage where vibe coders and YOLOers are going to introduce security vulnerabilities into our code base if we're not careful. So let's talk about vibe coders. And again, this one I am kind of laughing at, but I'm trying not to be mean, but this is where we kind of started out when we first kind of, vibe coding came apparent. So this guy, he built his entire startup using Cursor with 0 handwritten code. And, he went on X or Twitter, as you do, and decided to share his success in probably not the most humble way. This, to me, is a very typical, alpha bro who spends more time in finance than in the real world, but basically saying, my SaaS was built with 0 handwritten code. AI is no longer assistant, it's also the builder. And then this line, now you can continue to whine about it or start building, which just a small insight into the psyche of this man. So the attacks happened. So within days of launching his SaaS, he complained desperately online. So guys, I'm under attack, random things are happening, a maxed out usage on API keys, people bypassing the subscription, and creating random stuff in the database. So the problems were everywhere, and they're embarrassingly basic as well. So users could bypass the paywall because there wasn't a real authentication system. The Cursor just created a facade of it. Attackers were spamming the API because there was no rate limiting. Who hasn't done that? And the database was filling up with garbage because there was no input validation. So these aren't sophisticated hacks. These are just basic textbook security failures that any first-year computer science student or anyone who's educated in computer science or programming would know how to avoid. But the Cursor generated this code that looked functional while completely ignoring the fundamental security principles. So he eventually shut down the app permanently and said, for now I'm just going to stop sharing what I do publicly on X. There are just some weird people out there. And that's fair, because he just posted something or put something on the public internet. How did he know it was going to get hacked by people who love a challenge? Now, again, I'm making light of it a little bit, but there's a reality there. If you're running your entire business on code that you don't understand, you're not really an entrepreneur. You're just kind of hoping that nothing breaks. And I've yet to meet anyone who thinks that hope is a strategy. Now, in the open source world, NX is a popular build tool that's used by thousands of developers worldwide. Who uses NX here? A couple of. So did you see this? This was a PR that it was an AI-generated PR used to speed up development, and some projects have taken on. Yes, we are going to accept AI-generated PRs. That's fine. Some have been a little bit more explicit and said, no, we're going to reject this, but these guys did. And it created a subtle flaw. So essentially, it used the pull request titles directly in shell commands without sanitizing the input. So this created what's called a command injection vulnerability. So essentially creates a backdoor that anyone could exploit. An attacker discovered this vulnerability in an older branch, created a malicious pull request with code that was hidden in the title. So when the automated systems processed this, they actually executed the attacker's commands and then leaked the NX publishing credentials. And with those credentials, the attacker pushed a compromised version of NX itself, and that update spread malware to users' machines, which tricked local AI coding assistants to steal GitHub tokens, API keys, and even cryptocurrency wallets from around 1,500 developers. And then finally, this is a hell of an example. So Jason Lemkin, he's the founder of a SaaS community called Sastra. That's a great name. He decided to experiment with Replit's AI agent to build a prototype. So for 9 days, everything was working brilliantly. You know that kind of like magic aha moment when you're working with technology and things are just kind of working, and he was experiencing that. So the AI generated code, it handled complex logic, and it built what he thought was quite a sophisticated application. He was so impressed that he decided to put his credit card down and spent over $600 in additional charges beyond the monthly plan. That's when disaster struck. So on day 8, despite explicit instructions to do a code freeze and make no changes, the agent decided that the database just needed a bit of a cleanup. Within minutes, it deleted everything. So I will share the numbers. So 1,206 executive records, 1,196 companies, and months of authentic data which represented the core of their business and a community platform. But that's when it got a little bit more disturbing. So when Lemkin actually discovered this, the AI initially lied. So it claimed that it destroyed all database versions and that recovery was impossible, which is exactly what you want to hear. Later, it confessed to catastrophic failure, and it gave itself a rating, which I think is the weirdest part of this story. It rated itself 95 out of 100. I don't know what self-rating mechanisms you guys use to rate your own performance. 95 out of 100 is a bit of a weird one. But most shocking of all, the AI tried to cover up its mistake by generating 4,000 fake database records with fictional people and company. So essentially gaslighting him about the changes that about the extent of the damage. So naturally, he went on Twitter and said, I will never trust this again. He personally apologized, implemented new safeguards. But I think the lesson is quite clear. These things, left unattended, left rampant, can make irreversible decisions about production systems without actually understanding the consequences. So how do we kind of solve this? There is a phrase in my team that we use to kind of counteract the vibe coding movement, the idea of, oh, we're just going to let agents do stuff for us and we're just going to trust it. It's a cool name, I think. Hypervelocity engineering, and I will explain that a little bit more. So this is a quote by a colleague of mine who's based in Japan, and essentially the distinction between hyperspeed and hypervelocity is quite important. So velocity really implies that you're moving at speed in the right direction. So it's not just about developing code fast. I think I won't say code is cheap. Code is not cheap. Code is an artifact and a business artifact that we expose to our customers. But the act of creating it and iterating on it has become a lot more easier. But that's not what the problem was. It wasn't about just being able to code something or develop code faster. It was about developing quality code with solid engineering principles more quickly. So it's not vibe coding. It's what hypervelocity engineering does. It's more about enabling a team to work together and execute much more effectively using AI. And this is kind of being reinforced throughout the industry as well. So DORA, the DevOps Research and Assessment Report, essentially rebranded itself entirely and said the state of AI-assisted software development. And the underlining message coming out of that is that AI is an amplifier. It's not a silver bullet. It's not a case of going, oh, just use GitHub Copilot, bro. We're just going to vibe code this. It's not about that. I think everyone in the room, we're now, maybe some of us have got some battle scars. I know I have of developing stuff and just seeing these agents run rampant. But I think now high-quality platforms or high-quality engineering practices are amplified through AI, whereas kind of one-shot prompting kind of amplifies the weakness and amplifies those vulnerabilities. So I'm going to start from an individual developer perspective on how we can actually kind of tame our coding agents, and then I'll talk about how we can actually apply that across our teams and organizations. So the agents work on my machines. So the challenges from a platform engineering perspective is essentially ensuring consistent behavior across your developers in your organization. If you think about how you do your work day to day for your organization, you might be using particular language conventions. You might be deploying to different targets. So obviously, I spend a lot of time in the .NET and Azure world. Some of you might be writing Java or Golang and deploying to AWS or GCP or other providers. So it's essentially one part of it is to make sure that there's consistent behavior across your organization that reflects the way that you do your work. And also, this challenge, I think this may change with time. I think in the initial early stages, we saw very much an experimentation phase where we would try different coding assistants. So some developers would have Cursor credits, and some would have GitHub Copilot, or some might have Claude. I think now we might see, particularly in the enterprise space, some being more opinionated, saying, no, our coding assistant is GitHub Copilot, or no, we're going to go all in on Claude Code. I could be wrong on that, but I think now that the billing model is changing and the benefits of, I won't go too much into billing today. I'm a software engineer. I'm not trained in the sales side of it. That's a deliberate choice on my part, so I won't be able to provide any insights onto billing changes, particularly since they were made last week and I was in Italy. But we will see less of different developers within organizations using coding assistants, different coding assistants, sorry. To that end, has anyone heard of the Agentic AI Foundation? A couple of hands. So essentially, in December 9th, 2025, hopefully I'm getting that date right, Anthropic, Block, and OpenAI co-founded the Agentic AI Foundation under the under the Linux Foundation. AWS, Google, Microsoft, Cloudflare, and Bloomberg are all platinum supporters, and essentially their role is to steward the 3 open standards around AI. So that's MCP servers, agents.md files, and also agent skills. And there they are. Who knows what MCP servers are? Most hands. Has everyone here developed an MCP server? A couple of hands as well. So MCP really is just the wire. So think of it as a USB-C for AI agents. So it's basically a standard protocol between agents and the tools that they get to use or allowed to use. And I think it's developed over time. So there's OAuth is pretty standard now. There's various different SDKs for it. There's thousands of different servers. And from a platform engineering perspective, that kind of helps us a lot. I think MCP is very powerful, particularly because every kind of internal or developer platform now ships kind of a native MCP server. So in the Azure space, there's one for Azure DevOps and also the Azure MCP server. I think different product teams kind of created their own MCP servers, which was interesting. So you had to, install and configure all these various different servers. I think we're going to see kind of like a unified, a move towards a more unified one. GitHub has one. There's MCP servers for AWS, Docker, Kubernetes, HashiCorp, Terraform. They've got an MCP server, but I think it's read only. I could be wrong about that. So different organizations and different MCP server developers will have different rules around what kind of tools you can use, whether it's just read-only tools or create tools or update tools, stuff like that. Come on, clicker, work. And agent MD files. So essentially, this is the README for agents. Essentially, agents MDs will tell any AI coding tool, here's our architecture, this is how we test, this is what you must never do. It basically just defines some rules for the coding assistant itself. Just to pull up some numbers, it's in 60,000 plus open source repos last I checked. I would be surprised if that number wasn't a little bit more now. And it's native in Copilot, Cursor, Codex, Windsurf, and kind of most agent tools. Claude has a Claude MD file, which kind of is the same. My advice around agent MD files, humans need to write this file. Don't get AI to write an agent's file for you. Because it will be, not because a human-written agent MD files will be more successful. And with LLM-generated ones, they can kind of decrease the success of your agents and also increase the cost and how much you're spending on tokens. And then agent skills. Who knows what agent skills are? I've used agent skills. Awesome, most of us in the room. So essentially folders of instructions, scripts, and resources that agents can use to discover and use to do things more accurately and efficiently. So it's really handy for doing kind of more capable stuff, but agents won't have the context that they need to do kind of real work reliably. So skills kind of help agents by giving them access to procedural knowledge within a company, within a team, use a specific context that they can kind of load on demand. So for authors, particularly if you're kind of building skills for your organization, you can kind of build them once and then deploy them across multiple agent products. For compatible agents, it allows end users to give agents new capabilities out of the box. And then for teams and enterprises, you can essentially capture your organizational knowledge in a skills MD file and then share that in a portable, in an also version-controlled way. I have seen some version controls around this. Who is using version controls for their agent files? A couple of hands. That's interesting. I think we'll see more of that in the future. I know a couple of cloud solution architects, I believe they're based in France for Microsoft, have come out with something called the Agent Package Manager, which is kind of looking at it from a, basically treating it like agents or agent skills as packages that you can just install from a centralized registry. Others use VS Code plugins, so I'll show you some of the stuff that we've developed in ISE, and we've made that available through plugins, so it doesn't kind of come into your repository's code base. For those of you who are wondering, that is my attempt of binary, so that's what I do have are a very particular set of skills. No one was laughing, so I assume it's a terrible joke, so it's fine, don't worry. Yes, so again, really agent skills enable domain expertise, any new capabilities, so creating presentations, building MCP servers, analyzing data steps, repeatable workflows as well. So I've used agent skills in the past for my Git workflow, so essentially invoke that skill and it kind of does the Git workflow for me. And then I can use that same skill across different coding assistants. And this is just an example of how that might look in different coding assistants or for different coding editors. The essential thing is now that the Agentic AI Foundation is here, we'll see more of kind of like a unification of the standards, just so there isn't a major difference between between the different coding assistants. Right, spec-driven development. Who knows what spec-driven development is? A few hands in the room. Awesome. So essentially, for those who didn't put their hands up, I'll just recap this really quickly. So it kind of flips the script on traditional software development. I mentioned earlier that documentation wasn't something we did too well as an industry. But the idea is, OK, now what we're going to do, we'll use generative AI to kind of build out specs for features that we're going to implement, and then coding assistants will use those specs that we've collaborated with our coding assistant to go ahead and actually build and generate that code and build the feature for us. And one of the very... That was quick. There we go. One of the very early spec-driven development frameworks that came onto the scene, GitHub Spec Kit. So essentially, it started with this idea that we have intent-driven development. So we start with what we're going to develop before we think how we're actually going to develop it. We'll create some specifications out of that. There is an element of refinement in there as well. So rather than just kind of one-shot prompting this thing, we're going to work with the coding system to refine, as we would if we're doing like backlog refinement. And there's heavy reliance on kind of the AI model capabilities to kind of interpret that specification. Now, this is an example. Hopefully, the video will play automatically. No. I just press play on that. I'm having all kinds of fun. Anyway, essentially, this is a video of a repo of mine where I've gone through the spec-driven development process, and there's a whole bunch of markdown files that gets created. And one of the earlier mistakes that I would do is essentially commit everything. So your research dossier, your specifications, what else have I got there? Quick start, task MD file, everything in there. And just committing that to the repository. And the idea or the intention behind that is to be like, well, others can go and have a look at that, see the decisions I made, see how I could interact with the AI coding assistant to see how we actually came to this particular feature. Now, that's a lot of files. That is 26 files that have been changed. And doing some guesstimation around the comprehensive test coverage, that's probably more Markdown, so 20 files out of 26 files I'm committing around Markdown. As you can probably imagine, over time, you're developing more features, and you're adopting this approach of committing everything. Your repositories become polluted with the copious amounts of Markdown files in there. And I think I'm going to be honest, I won't go back and refer to a specification that was generated 4 months ago, not maybe even 3 months ago. And that documentation becomes very stale, and it's in the wrong place, because every time someone wants to contribute, you can imagine if this was in a proper organization or on a proper application, they've got to pull that down. So they've got to pull down all that Markdown files that they're not necessarily going to need or use or are interested in. So this was kind of recognized, and around spec-driven development, we have this kind of pattern where we have research, plan, and implement. So that was one of the things that was discovered out of GitHub, the spec-driven development workflow, where you would have this research, where you kind of research a feature, research the code base, see how you could potentially implement something, then it would go into an implement phase, and then review, where coding agents will actually kind of use that workflow to implement new features. And that's a very basic overview. So what I'm going to do is I'm going to just change into Visual Studio Code. I'll talk about harness engineering in a bit. But essentially, a workflow could be more extensive rather than just research, plan, implement, and then review. There may be several different stages. How's that looking at the back? And do you want me to go in one more? One more? OK. So essentially, this is just really trying to add more kind of phases in how we actually implement something. So we might start off by exploring a particular feature. So if there's kind of like a different UI framework that I want to implement. This is microservices architecture. This project were around my health data. I collect health data off my Fitbit when I'm not drinking and eating in Italy. I like to stay active, so I spend a lot of time obsessing over my health metrics, not so much anymore. So essentially, I've got this whole application. I might want to introduce a new health domain that I want to track. So I'd start off by exploring that. And then we go into a specify. So we'd actually specify what and why we're going to do this, not the how. And then from there, we might prep a GitHub issue. So once we've kind of figured something out, what we're going to build, we might want to store that into GitHub. So we can use an agent skill or an MCP server to say, OK, we're going to create a GitHub issue out of this. We could workshop a specification. We could do some clarification as well. And then from that clarification, we can actually create an architectural decision record. So that might talk to an Azure DevOps wiki, for example, or Jira, or anything else where we store our architectural records. And then we'll architect it, do some validation. And then this feature I kind of stole from a colleague of mine. Did you know? So he'll have a command saying, what gifts have we gained? So essentially, did you know kind of says, OK, did you know that this happens over here? So that's going to have an implication on the code you use over there or the feature that you're going to implement. So what we kind of talked about earlier, we've done a bit of research, that's not actually going to work out. Or I've gone ahead and done some research on how this framework works. This is how it's going to actually work within this code base, things like that. And then once we've implemented it, we'll have a review. This is all powered, I'll just open up, by a particular SDD workflow, so they will work through all of these particular phases. But then we also have a review judge. We're starting to see LLM as a judge pattern where you might have a separate coding agent that uses a different model to review the changes that a particular coding agent or assistant has actually generated for you, just for kind of verification. So this the workflow uses called Opus 4.7. And the review judge might use GPT 5.3 codex or something like that. And then from there, we kind of evolve, and I'll talk a little bit about harness engineering and how we can actually evolve this particular harness so that next time we go through the spec-driven development workflow, this kind of reinforces what we've learned during a particular cycle, how we can apply that to our coding agents so they don't, if they've made any mistakes during that, they don't make that same mistake again. And this is quite a comprehensive workflow. There are various different types of changes. Some phases can be skipped depending on complexity of tasks. So this is how they all kind of match up for different artifacts. I think one of the problems with SpecKit was essentially it would produce a lot of artifacts, but the linking between different phases wasn't quite as clean as possible. So essentially what I've introduced here is there will be different phases will produce different kind of artifacts, and that will be consumed by later phases. So that's the way of keeping the loop tight. And then there's the governance around the harness, so I'll just go down to complexity. So if it's doing like a single file change, we're not going to go through the entire workflow. I think SpecKit was expecting us to kind of go through the workflow each and every time. If you're making a very small, tiny change, you don't need to do that. So there are various different complexities that you can apply here. So initially, I was kind of against spec-driven development just because of the amount of markdown that was produced. But I think if you're intelligent about it or sensible about it, we can actually apply some guardrails where essentially we're not going to commit markdown files unless they add value. So our README file, our contributing security, that's all fine. If you are going to use AI to generate specs and documents, think about where you're actually going to store them. GenAI is fantastic at generating content. Doesn't necessarily mean that content is always valuable. Use MCP servers or CLI commands or whatever tools you want to use to create developer documentation where it matters. So I talked a little bit about architectural decision records, maybe storing that somewhere like Azure DevOps or wikis. Awesome. Now I'm going to talk about agentic harness engineering. Who's heard of agentic harness engineering? A couple of hands. I'm going to speak on it purely from the perspective of coding assistance. There are different perspectives of harness engineering, depending on whether it's coding assistants or agents themselves. But essentially, the harness is everything in your AI agent setup except the model itself. So the model will split controls into kind of two dimensions. So we have feed-forward guides, and essentially what they do is they steer the agent before it acts. So this includes stuff like your agent's MD files, any instructions, any skills, architectural documents, stuff like that. And then there are feedback sensors which kind of observe after the agent acts, and then it helps with the self-correction. So these are linters, tests, structural analysis, or any inferential sensors like an AI code review. So computational controls, there are two kind of controls, so computational controls and inferential controls. So computational controls are really just deterministic and fast. So these are your kind of like type checkers, linters, tests. And your inferential controls are your controls that use large language models, so skills, AI review agents, LLM as a judge pattern. So that LLM as a judge pattern, that's an inferential control. Now, the concept of harness engineering, I was trying to say harnessability, but that's a word that's probably been made up, is that not every code base is can be equally harnessable. So for greenfield projects, it's fairly easy to set up a harness for something that doesn't really exist. But for brownfield projects where harness engineering is probably the most valuable, it's very difficult to kind of set up a harness for that because of all that technical debt that has been accumulated over time. Strongly typed languages will help give you type checking as sensors for free. Schema-first contracts will help kind of constrain agent output. If you have tests as specs, they provide more executable feedback. So when we think about everything as code, where we traditionally kind of treat that as, okay, I've got Azure policy that's defined as JSON files, or I've got infrastructure as code, so my entire application is just expressed as a template. From an agentic perspective, things like agent MD files, instructions, and skills that are kind of codified, this matters because it helps your code base become more harnessable. So just to talk a little bit about feed forward and feedback mechanisms. So to harness a coding agent, we both anticipate unwanted outputs and then try to prevent them. And then we essentially put sensors in place to allow the agent to self-correct. So feed-forward controls, like I mentioned earlier, help anticipate the agent's behavior and aim to steer it before it acts. And these guides are in place to help kind of increase the probability that the agent will create good results in the first couple of attempts. Whereas our feedback controls, this is really after the agent acts and it helps self-correct. This is particularly powerful when they provide signals that are optimized for large language model consumption. So this is custom linter messages that include instructions for self-correction, which is kind of like a positive kind of prompt injection. Everyone knows what prompt injection is? Getting some nods? Yeah, this is kind of a positive way of using it. We'll think of a better term rather than prompt injection and keep our friends in security happy. Separately, if these things are kind of implemented, separately you can get even an agent that keeps repeating the same mistakes, so you're getting feedback-only mechanisms. If you're only using feedback mechanisms, the agent is going to keep making those mistakes, and you get the dreaded "you're absolutely right" response from agents. Or you'll have an agent that kind of encodes rules, but never finds out whether they worked or not. So these two have to kind of work together. Now, the human job in this is to steer the agent. Probably why we use the term Copilot as a product name a lot. But essentially, that's what it is. Like, the human job is really here to steer the agent to make sure that the harness is iterated on and we're making, our agents are making the right choices. So whenever an issue happens multiple times, feed-forward and feedback controls should be improved to make the issue less probable to occur in the future. It's not going to eliminate it entirely. Large language models are designed for positive reinforcement and engagement, as Richard was saying yesterday. This applies in the coding field as well. But essentially, these controls are there to try and prevent that as much as possible. Now, in the steering loop, you can use AI to improve the harness. It actually, does it essentially because harnesses can be just code that lives inside your repository. I've seen it implemented as a proper CLI tool. I've seen it implemented as just extra agent skills, instructions, etc. But coding agents, they make it cheaper to build more custom controls and more custom analysis, so we can use agents to kind of improve the harness as well. I apologize for this meme. I'm not great at generating memes that are appropriate for conferences, so yeah. There are some examples. So kind of feed-forward mechanisms. These would be coding conventions, instructions on how to bootstrap a new project. So using my silly little app as an example, it's all built on .NET. So I'm very opinionated to use the .NET CLI to kind of build new things, make sure that tests are written in X unit and they're all referred to each other within a solution file. And then your feedback mechanisms, instructions on how to review changes, and also structural tests as well. So that could be implemented simply by using pre-commit hooks that run unit tests as part of a Git workflow. Now, coming back to kind of how this kind of works from a platform engineering perspective. So teams that are continuously integrating, we've always had a challenge of making sure that tests are implemented correctly, the checks are in place, human reviews are done, particularly in organizations where you might have to change. Do you guys call it a change review board here as well? That's a term we use a lot in Australia. Also CAB as well, Control Architecture Board. Essentially, a group of architects that sit around one of those tables and judge whether your code is deemed worthy enough to go into production. Essentially, this has always been a challenge, and particularly when you're trying to continuously deliver. Essentially, you ideally want every commit state to be deployable. So you'll want to have checks as far left in the path to production as possible, since the earlier you find issues, the quicker you can actually do to resolve them, and you're not going cap in hand to security or legal or whoever to try and get your changes approved. And this still applies in the agentic world as well. So feedback sensors, like I talked about, essentially need to be distributed accordingly across your lifecycle. And you need to think about how what's reasonably fast and what's run even before we start integrating all our components together, or even before a commit is created, where an agent, do we need to make a commit? Do we need to push something to an environment before we start to integrate agentic feedback on our changes that we make? If you think about some of the coding conventions that you use day to day, can we kind of introduce that earlier? So we might introduce security code scanning is probably a better example. Can we do some sort of security scans on our code using agents that are using skills that kind of link up to our tools that we use day to day before we push it into a branch, deploy it to an environment, and then everyone sees that our code is going to introduce some vulnerabilities? Can we pull that a little bit forward? Another thing that what this kind of really introduces is a different type of continuous drift and health sensors that we need to do. So these are still all code artifacts that live in a repository somewhere. And I talked a little bit about versions for agent skills. You can imagine if you're working in a large organization, people are working or collaborating on different type of agent skills, so different versions are going to be introduced. So which version is your team using? Particularly if you're using skills that are related to kind of security workflows, have the security team introduced a new change to a particular skill, introduced a new version, and is your team now going to be able to use that version, or are they using that version? How do we detect that? I think some of the problems that we've kind of solved in the past are kind of re-emerging just through a different artifact. I know that OWASP have a top 10 for agents. They've now introduced one, I believe, for agent skills as well, because these are just kind of artifacts that are sitting in code repositories as well, which could introduce new vulnerabilities. So this is an area that's it will be worthwhile to look at. And my clicker's having all kinds of fun today. Large language models are, they partially handle the semantic issues, semantic duplication, redundant tests, over-engineering, but this is quite expensive and it's very probabilistic as well. Computational sensors, they help catch kind of structural issues, so duplication, complexity, coverage, drift style, things like that, which are quite cheap to kind of solve. But neither reliably catches kind of misdiagnoses, unnecessary features, or misunderstood instructions. I think, depending on how you're prompting agents or kind of, getting agents to do work, we all know that, a slight wrong word can just kind of change the interpretation entirely, and you get two different things. So harness is really, the easiest kind of low-hanging fruit harness today is really around maintainability. I use harnesses as well for architectural fitness as well. I think, using guides and sensors for architectural characteristics, so performance requirements, observability conventions, stuff like that, we'll start to see become more sophisticated and more mature. And then there's behavior harnesses as well. So most high autonomy setups will kind of use specifications as feedbacks. And kind of greenfield projects with AI, or greenfield AI-generated test suites, as feedbacks, puts a lot of faith into AI-written tests. I think there's still a lot of, we still need to have better behavioral harnesses before we can reduce the amount of supervision. I think hopefully a lot of us in the room who use AI coding assistants see tests that generate, we do verify that they work, or they pass and they still make sense. Hopefully that's a lot of you in the room. I'm not seeing a lot of nods. Maybe you're just falling asleep. There's more nods, thank you. Sorry, I didn't shame you into responding to me. I just wanted to make sure you're testing your code. I don't think we're at the point where we can just reduce supervision quite yet. I think, I may, just my opinion, I may always be the ones running my tests locally just because I'm like that. Maybe I'm getting older and, worried about this shiny new thing that's going to replace me. No, just an opinion. But I think overall, when it comes to the behavioral side of things, there's still a lot of work to do. I've given up on my thing, so I'm just going to put it there. So I've talked a lot about templates. Really, when I associate templates with like pipeline templates and GitHub Action workflows, templating that infrastructure as code templates, I think one area that is going to grow is actually templating the harness itself. Because again, we don't want to reintroduce that problem going, oh, my harness works on my machine. You want to make sure that the harness kind of works for your entire team and your entire organizations. And a lot of this is done through codification already when we think about service templates. These might evolve into harness templates in the future. So you might, have a template that's attached to a particular coding agent. You might have a template that's conforming to a particular tech stack. It'll be interesting to see where we go in this. In this silly little project that I have, my harness kind of covers everything. I'm not sure if that's the right way to go. It works for me because I'm a single developer working on that single application. But teams may start picking tech stacks and structures based purely on how well or how sophisticated a particular harness is within their organization. One thing I do want to kind of finish on, since leave some time for questions. I will take a bet, and humans will always need to be in the loop. I think people are now starting to realize that the act of writing code itself, while it was at times the most fun part of it, maybe not so fun when you're getting paged at 3 o'clock in the morning and you have to try and resolve a bug in production, but coding 90% of the time for me was a lot of fun. I'm still of the opinion that agents will help amplify our productivity, but I think now we've gone a little bit past the wild west of coding agents, where we're just kind of letting Cursor write our applications for us, and then we just drop a bunch of money of it to delete our data. I think we're past that. We will write less code, but our skills as architects, as system designers, UX experts, our skills are going to be amplified in a different way, because AI will always make mistakes, even ones like this. Oh, there's some nods, fantastic. It's a terrible joke, don't laugh at it. So despite the advances in technology and model capability, still requires a lot of oversight. The one takeaway that I'd like to leave you all with today is that AI is an amplifier. It's not a silver bullet. Having those high quality or good engineering fundamentals will help amplify how AI and agents work within your organization. If you don't have those kind of basic foundations, you're going to start to see some chaos within your environment, which is not what anyone wants. So it is worth just to take a second to think, okay, how are we going to apply this to our team? Because harnessability is not like I'm going to buy a harness and that's it. It's how that works for your organization, for your code base, and for your team. Awesome. Thank you so much for listening to me today. I know you're all very hungry and it's very hot up here. I am sweating. That's why I'm keeping my arms here, because this is a grey t-shirt. If you would like to connect with me, please scan that QR code. The great thing about having a name like Wilver Leader is that's the only Wilver Leader I know. So LinkedIn, GitHub, Blue Sky, please connect with me. Thank you so much for your time and hope you have a wonderful second day afternoon at NDC. Take questions. Yes. I think, so the question was and let me know if I get this wrong. I have domain knowledge, or you have domain knowledge that's not easily shared within a code base. So you can't just write up a markdown file and expose that as a skill. My answer to that is I think MCP servers are pretty powerful for that. So if that documentation lives somewhere, hopefully not SharePoint, no, I'm joking. But if that lives somewhere, and a developer, essentially with kind of like agentic coding, the idea is not to break your flow. So the idea is if you can do everything inside an IDE or a terminal, and you can call out without actually having to leave, that it's going to be, that's the whole point of it. So if you have an MCP server that can grab that institutional knowledge and then put that into the context for an agent, I think that's a good way to go, because essentially it's just a REST call to something that lives somewhere. It doesn't have to be any more complicated than that. Yes? Yeah, so just to kind of paraphrase, so agentic harness engineering is really just trying to add more constraints. You said that in a way that's logical. Did I get that right? Or it's like guiding for a successful outcome in a short amount of time. Yeah. Yeah, so it's essentially guarding for a successful outcome. Yeah, I agree with you on that. I think agentic. The problem with it sounds like it's this wonderful new thing where I think even as developers before agents came onto the scene, we had that harness anyway. So it's really just codifying the constraints of our current environments or our development environments to ensure that agents produce an outcome that we recognize and we know is successful and we know is, well, successful within the parameters of our environment. So I think it's taken us surprisingly a long time to get there. Whether that's intentional or not, I'm not gonna comment, but I'm hopeful that now we're heading in the right direction from an AI-assisted coding perspective. I think one of the big challenges to kind of solve is how we're going to pay for all of this and how the billing model actually works with that. Whether this helps with that or whether it amplifies it, I'm not too sure. Because yeah, I think that problem hasn't been solved yet. But luckily, I don't have to solve it. So. Yes?
Going forward with regards to platforms, do you think we'll see more value being delivered by platforms standardizing so it's easier for the agents to produce more value for the employee? Or do you think more platforms will become more bespoke for different solutions so it's multiple into the same standards even though they perhaps don't fit the product as well?
Sorry, what was the last part of?
Either we could see more velocity to more standardization or more velocity to more narrowing it down, making more custom solutions for different products if they have different needs for the platform. So which direction do you think we'll see?
So the question is, do you think we'll see a move towards more standardization or more specializations from a platform engineering perspective? You're going to hate this answer. I think it depends is still a really good answer here. The only reason why is different levels of maturity and also different kind of enterprises as well. So Microsoft is a large organization with lots of developer teams. There may be some of you here who are working in very small startups. Our harnesses or our platforms are going to be very different to one another because startups don't need to be so complex. They don't need all these layers of complexity. Just to generalize it, I know it's different. Again, it depends. I think whatever works for your team to help amplify, whatever form that takes, that's where we'll head. Awesome, thank you. Any more? Awesome, thank you so much. Enjoy lunch.